So, what if an AI could do more than just, write code? What if it could actually think like a seasoned software engineer? I'm talking about hunting down bugs, debugging these massive complex systems, and just fixing problems all on its own. Well, that's exactly what a new piece of research is digging into, and trust me, the results are kind of mind blowing.
And this is a really critical question, right? We all know AI models like GPT-4 are fantastic at spitting out code from scratch. You give it a prompt, it gives you a function. But that's not really what most software engineers do all day. The real work, it's more like parachuting into a million lines of code you've never seen before to find one tiny hidden bug. So the big question is, can AI actually do that?
And this really gets to the heart of the difference. You can think of today's AI models as amazing coders. They're great when they start with a blank page. But a true engineer, oh, that's a whole different ballgame. An engineer has to navigate this tangled web of existing code, debug stuff that's already broken, and solve problems inside a system someone else built. We're talking about a completely different skill set here.
So this is the exact challenge that researchers took on. How do you level up a great coder and turn it into a real deal engineer? And the problem, it turns out, really boils down to the training. See, most models learn from these huge static snapshots of code. They see the perfect finished product, but they totally miss the most important part, the messy human journey of how it got there. They don't see the bug reports, the late-night developer arguments in the comments, all the failed attempts, and of course, that final aha moment when the fix is found. So to fix this, the researchers decided to build a whole new kind of training ground, one designed specifically to capture that entire messy process. They call it SWRL, and the idea behind it is, well, it's actually pretty simple, but incredibly powerful. Instead of just showing the AI the final clean code, they decided to show it the entire story of how that code came to be, warts and all, especially how it gets fixed. So where do you even find data like that? Well, you go to GitHub, which is basically the largest library of human problem solving in software history. The researchers grabbed almost a decade's worth of activity. We're talking every bug report, every developer discussion, every single pull request with a fix. The AI got to learn directly from millions upon millions of real-world examples. Okay, so having all this data is one thing, but how do you actually get an AI to learn from it? This is where things get really clever. They used a technique called reinforcement learning, which you can basically think of as a very, very sophisticated form of trial and error. So here's the 10,000-foot view of how this works. The AI gets a real bug report, and it takes a shot at fixing it. Then its proposed fix is compared against the solution a real human developer came up with, and based on that, it gets a score, or a reward. Now let's break down exactly how that feedback loop works step by step. All right, it's basically a four-step cycle. Step 1, reason. The AI studies the bug report, looks at the code, it thinks through the problem, just like a human developer would. Step 2, predict. It generates a patch, the actual lines of code that it thinks will fix the bug. Then step 3, compare. Its patch gets compared to what's called the Oracle patch, which is just the fancy term for the solution the real human developer came up with. And finally, step 4, reward. It gets a score. If it was a good fix, it gets a high score. If it was a bad one, it gets a penalty. And it just does this over and over and over again, getting a little bit better with every single loop. Honestly, you can think of it like this. It's like a video game for the AI. It's playing Fix the Bug. Every good move, every correct line of code gets it points. Every bad move costs it points. And just like any of us playing a game, it starts to figure out the strategies. It learns what works to get that high score.
So, after all this intensive training, after playing this game millions and millions of times, how did it do? Did it graduate? How well did it actually perform when put to the test on real-world problems? The result? 41%. On a really tough industry benchmark, this newly trained model was able to fix 41% of real-world software bugs all by itself. I mean, just let that sink in for a second. Almost half of the problems you could throw at it, it could solve, completely on its own. But you might be wondering, is 41% actually good? Well, let's put it in context. Let's look at the leaderboard. GPT-4o, one of the best models out there, clocks in at about 23%. Claude 3.5 Sonnet does better at 33.6%. But this new model, Llama 3, with the SWE-RL training, it leaps all the way to 41%. That isn't just a small step up, that is a massive jump in capability. Okay, but here's where the story gets really interesting. This is the big twist. The researchers discovered that by teaching the AI to be a better software engineer, they had kind of accidentally made it smarter at, well, almost everything else.
Which raises a huge question, right? Did it just get better at pattern matching code, or did something more fundamental change in the way it actually reasons about problems?
Well, the researchers started noticing what they called aha moments. The AI wasn't just throwing code at the wall to see what stuck. It was actually developing real skills, like being able to reflect on its own work and breaking down big, complex problems into smaller, logical steps. And the craziest part? This wasn't just happening with code. It was happening with logic puzzles and even math problems. And this is really the big reveal of the whole paper. It turns out that the skills you need to be a great software engineer, logical deduction, step-by-step problem solving, wrapping your head around complex systems, those skills are incredibly transferable. The training didn't just stay in its lane, it generalized. And they've got the numbers to prove it. Before this special training, the base model scored about 63% on a difficult math test. Afterwards, its score shot up to almost 74%. That is a 10-point jump in mathematical reasoning that it learned just by fixing code. It even got a little bit better at general knowledge, too. So the really crucial point here is this. Teaching an AI to be a great software engineer also made it a better all-around thinker. The complex, logical puzzle of fixing software might actually be one of the best ways to teach an AI how to solve problems in general. And that's a pretty profound idea when you think about how we build smarter AI in the future. And that kind of brings us to the final big picture thought. This research points to a whole new way of thinking about AI training, and it leaves us with a really fascinating question. What's next? What does the world look like when AI can fix bugs even faster than we can write them?